Spring 1943, England. British Spitfire veterans and German Luftwaffe intelligence observed the arrival of America's newest fighter, the Republic P-47 Thunderbolt. Fully loaded, it weighs over 7 tons, roughly the size of a light bomber. To the experienced pilots of the European Air War, it looks entirely too massive and sluggish for dogfighting. It visually contradicts every established rule of agile fighter design. Sent to face the world's most experienced Air Force, the Thunderbolt is immediately ridiculed as a flying milk jug. Yet this bloated, heavy machine is about to become one of the deadliest and most survivable weapons in the European theater. The Thunderbolt was not the result of poor engineering. It was a radical departure from conventional fighter philosophy, constructed entirely around a massive 2,000 horsepower radial engine. Hidden within that bulky fuselage was a complex internal turbocharger system. Chief designer Alexander Kartveli built the P-47 to thrive at 30,000 feet, an altitude where thin air choked standard engines. Up there, it was a high-speed predator. But the immediate, unforgiving reality of the 1943 European Air War was not fought in a high-altitude vacuum. The 8th Air Force needed escorts, frequently dragging pilots down into swirling, low-altitude dogfights against seasoned Luftwaffe veterans. Down in the thick air, the heavy American fighter was severely disadvantaged by slow initial acceleration and strict logistical constraints. To survive, these squadrons had to fundamentally unlearn how to fight. How does a machine apparently built to defy the basic principles of maneuverability learn to weaponize its immense mass, transforming its greatest apparent weakness into a lethal tactical advantage? By early 1943, the United States 8th Air Force is bleeding. The American doctrine of daylight precision bombing relies on the theory of the self-defending bomber formation. Armadas of B-17 Flying Fortresses and B-24 Liberators are sent deep into occupied Europe, bristling with 50 caliber machine guns, theoretically capable of fending off fighter attacks without escort. The theory is failing catastrophically. The Luftwaffe's seasoned interceptor squadrons are tearing through the unescorted bomber streams, inflicting unsustainable losses. The 8th Air Force desperately needs a fighter capable of escorting the heavies all the way to the target and back. The arrival of the P-47 Thunderbolt into combat units, specifically the 4th and 56th Fighter Groups in April 1943, is supposed to be the answer. But the immediate reality of deploying this massive machine is plagued by a crippling logistical flaw: fuel consumption. The R2800 double WASP engine is a marvel of power, but it is notoriously thirsty. With its standard internal fuel capacity of just over 300 gallons, the Thunderbolt has an absolute combat radius of roughly 230 miles. This creates a devastating tactical rhythm. The Thunderbolts can escort the bombers across the English Channel, covering them over the coastal fringes of France and the Low Countries. But just as the bomber formations push deeper into hostile territory, crossing into the airspace where the Luftwaffe concentrates its primary interceptor rings, the P-47 pilots watch their fuel gauges drop. They reach their absolute turnaround point just as the German fighters begin their coordinated massed attacks. The American fighter pilots are forced to bank away and head for England, leaving the bombers completely exposed in the deadliest skies on Earth. When the P-47s do manage to engage the enemy near the coast, the results are deeply troubling. The fundamental problem is a severe mismatch between American pilot training and the physical realities of their aircraft. Pre-war pursuit doctrine and the lingering romanticism of World War I dogfights dictate a specific way to fly: the horizontal turning fight. Pilots are taught to pull tight, looping maneuvers, attempting to outturn the enemy to get onto their tail. The veteran pilots of the 4th Fighter Group, many of whom had previously flown nimble British Spitfires as volunteers, instinctively try to fly the 7-ton Thunderbolt the exact same way. They are going up against a Focke-Wulf FW-190. One of the premier interceptors of the war. The German machine features a lighter wing loading and an exceptional roll rate. When an American pilot tries to haul back on the stick and turn inside a Focke-Wulf, the immense weight of the P-47 aggressively fights back. In a horizontal turn, the heavy Thunderbolt rapidly bleeds off its airspeed. Its massive frame begins to wallow in the thin air, losing the critical energy required to maneuver or escape. The Luftwaffe pilots quickly recognize this flaw. German veterans, commanded by tacticians who had honed their skills over France and the Eastern Front, easily outturn the stalling American machines. They bait the Thunderbolts into low-speed horizontal engagements where the American fighter's size becomes a fatal liability. Early combat reports from these encounters are grim. To the Luftwaffe intelligence officers analyzing the after-action reports, the new American fighter appears to be exactly what it looks like: an oversized, sluggish, and clumsy target that poses little threat to a skilled German pilot in a turning fight. This fundamental tactical mismatch leads to painful early losses for the 8th Air Force fighter groups. It thoroughly reinforces the German assessment that American engineering has produced a deeply flawed machine. The heavy fighter is consistently outturned, outmaneuvered, and outfought in the traditional horizontal arena. But the American pilots are slowly realizing that fighting on the enemy's terms is a death sentence, and the unyielding laws of physics are about to offer a brutal, entirely different alternative. To survive, tactical leaders in units like the 56th Fighter Group realized they had to stop fighting a European war of aerodynamics and start fighting a war of pure physics. The key to this new doctrine was already built into the aircraft, hidden deep within its bloated belly. That massive, deep fuselage was not just dead weight, it was a complex ducting system housing a state-of-the-art exhaust-driven turbocharger. Instead of staying low where the heavy fighter wallowed, American pilots began hauling their squadrons up to 30,000 feet. Up in the freezing, oxygen-starved stratosphere, a fundamental mechanical shift occurred. The Focke-Wulf 190's radial engine began to gasp for air, rapidly losing critical horsepower. The Thunderbolt's massive turbocharger, however, force-fed compressed oxygen into the engine, allowing the P-47 to thrive exactly where the enemy choked. This altitude gave the Americans the ultimate currency of aerial combat: potential energy. When Luftwaffe formations were spotted below, the P-47s no longer tried to turn with them. They rolled inverted and dropped. But the most lethal revelation came when German pilots reacted to this new tactic. For years, the standard Luftwaffe defensive maneuver, when caught at a disadvantage, was a steep, full-throttle dive. Against a lighter, more fragile British Spitfire, it worked perfectly. The British aircraft simply could not keep up in a terminal plunge without risking catastrophic structural failure. When a Focke-Wulf pilot instinctively tried to dive away from a Thunderbolt, however, he triggered a fatal trap. The immense 7-ton mass that made the American fighter so sluggish in a horizontal turn suddenly became an unstoppable engine of kinetic energy. Gravity took over entirely. In a steep dive, the P-47 accelerated with terrifying velocity. German veterans looking over their shoulders during an evasive plunge, expecting to see empty sky, instead found the massive cowl of a Thunderbolt rapidly closing the distance. The American fighter easily caught the fleeing interceptors in a terminal dive that would have ripped the wings completely off a lighter airframe. By refusing to turn and choosing to drop, the Thunderbolt had finally learned to weaponize its own weight. With the realization that the 7-ton Thunderbolt could outdive anything in the European sky, American pilots had finally cracked the code of its mass. But catching a fleeing Focke-Wulf was only half the tactical equation. Destroying it required a specific application of firepower. Alexander Kartvel's design did not rely on a few synchronized machine guns firing through the propeller arc. Instead, the Thunderbolt housed a devastating battery of 8 Browning M250 caliber machine guns, 4 mounted deep within each of its massive wings. Because the weapons were set wide apart, armorers back in England had to carefully calibrate their trajectories, angling them slightly inward so the streams of lead would converge at a specific, lethal point ahead of the aircraft, usually between 250 to 300 yards. Furthermore, the ammunition belts were staggered. The outer guns were loaded with slightly less ammunition than the inner guns, ensuring that even in a sustained firing pass, the pilot's center of gravity wouldn't abruptly shift as the outer wing sections became lighter. When a P-47 plunged from 30,000 feet and caught a German interceptor in its crosshairs, the American pilot squeezed the trigger on the control stick. The 8 Brownings unleashed an overwhelming volume of fire, spitting out roughly 100 heavy, armor-piercing and incendiary rounds every single second. It was a literal wall of kinetic energy. But just as crucial as the kill was what happened immediately after. The Thunderbolt pilot did not pull the throttle back and enter a turning fight to confirm the hit. Instead, operating strictly on the newly formulated boom and zoom energy tactics, the American pilot used the immense speed generated by the terminal dive to haul back on the stick. The heavy fighter pitched its nose up and rocketed back toward the stratosphere. The P-47 simply converted its kinetic energy back into potential energy, zooming thousands of feet upward at a climb rate that the lighter German fighters, having bled their energy attempting to evade, could not possibly match. By the time a surviving Luftwaffe pilot oriented his aircraft to fire back, the Thunderbolt was already a receding dot in the sky, completely untouchable, rearming its altitude advantage for another strike. This brutal vertical warfare was working, fundamentally shifting the balance of power at high altitude. But this tactical success was operating on a strictly enforced, violently short leash. The Thunderbolt was still burning through its 305 gallons of internal fuel at an alarming rate. Throughout the summer and early autumn of 1943, as the 8th Air Force launched deep penetration raids against German industrial targets, like the ball bearing plants at Schweinfurt, the P-47s hit their turnaround points far too early. German interceptor controllers tracked this dynamic perfectly on their radar screens. They simply held their elite fighter wings in reserve, waiting patiently just beyond the Thunderbolt's maximum combat radius. The exact moment the American escorts hit their fuel limits and banked away toward the English Channel, the Luftwaffe pounced on the unescorted heavy bombers, turning the B-17 streams into burning graveyards. The solution to this operational crisis was not found in aerial maneuvers, but in intense engineering and logistical adaptation on the ground. The 8th Air Force desperately needed external drop tanks to extend the P-47's reach, but simply strapping a fuel barrel to the belly of a fighter flying at 30,000 feet presented a massive physics problem. At that altitude, the ambient air pressure is so thin and the temperatures so extreme that standard fuel pumps would cavitate, failing to draw gasoline from an unpressurized external tank. Engineers and ground crews worked frantically to develop and refine a system that utilized excess air bled from the aircraft's vacuum pumps or the exhaust-driven turbocharger system to artificially pressurize the external drop tanks. By forcing compressed air into the disposable tanks, the fuel was literally pushed up into the Thunderbolt's main internal fuel lines, regardless of the thin atmosphere outside. They started with 75-gallon teardrop metal tanks, then moved to 108-gallon compressed paper tanks built by the British, and eventually mounted massive 150-gallon belly tanks. The logistical effort required to manufacture, ship, and plumb tens of thousands of these disposable tanks across the Atlantic was staggering, but the result was a tactical earthquake in the skies over Europe. For months, Luftwaffe intelligence had assured its fighter commanders that American escorts possessed a rigid, predictable tether. German pilots were briefed on exact geographical lines on their maps where they would be safe from the heavy American fighters. Then, in late 1943, the impossible happened. German interceptor squadrons climbing to meet the American bomber formations deep over German territory suddenly found themselves engaged by P-47s. The American fighters materialized hundreds of miles beyond their supposed absolute limit. When engaged, the Thunderbolt pilots would simply hit a release switch, eject their empty external tanks, instantly shedding the drag and weight, and pivot directly into their lethal boom and zoom dives. The enemy perspective shifted dramatically and violently. The Luftwaffe veterans, who had initially dismissed the aircraft as a clumsy, overgrown target, rapidly began circulating frantic tactical warnings. Internal German combat memos were revised with extreme urgency. The primary directive was clear. Under no circumstances should a pilot attempt to dive away from a Thunderbolt. The physical reality of a P-47 attack was proving too destructive for the lighter German interceptors to withstand. The Focke-Wulf 190 and the Messerschmitt Bf 109 were remarkable machines, but they were built for agility and speed, not to absorb heavy punishment. When caught in the convergence zone of a Thunderbolt's 8 machine guns, the German fighters did not merely sustain damage, they were physically disassembled in midair. The concentrated kinetic impact shattered wing spars, detonated internal fuel cells, and sheared off control surfaces. The heavy American fighter was systematically pushing the Luftwaffe out of the high-altitude sanctuaries they had controlled for years. However, the war in the air was a constantly mutating ecosystem. By early 1944, the strategic landscape shifted yet again. A new American fighter, the North American P-51 Mustang, began arriving in theater in significant numbers. Equipped with a highly efficient, liquid-cooled Rolls-Royce Merlin engine and a massive internal fuel capacity, the Mustang was inherently capable of escorting the heavy bombers all the way to Berlin and back, surpassing even the most heavily modified Thunderbolts in sheer range. The Mustang steadily took over the deep penetration escort duties, but the Thunderbolt was not obsolete. Its true trial was just beginning. The Allied command was rapidly building the 9th Air Force, a vast tactical air army designed specifically to prepare the continent for the impending invasion of Europe. They did not need a high-altitude escort. They needed a brutal, low-altitude attack platform to isolate the Normandy beachhead, destroy rail yards, and obliterate German armored columns. The Thunderbolt was reassigned. Squadrons that had spent a year mastering the freezing, pristine combat environment of the stratosphere were suddenly ordered down to the deck. They plunged from 30,000 feet down to 50 feet. The environment shifted from the vast open blue skies to the smoke-filled, muddy, and tree-lined terrain of northern Europe. This was a fundamentally different war. At 50 feet, the enemy was no longer a Luftwaffe ace in a Focke-Wulf. The enemy was the ground itself and the most concentrated, lethal anti-aircraft network the world had ever seen. The German military had spent years layering the continent with thousands of 20mm and 37mm flak cannons. Every rail junction, every convoy, every bridge, and every crossroad was heavily fortified. Down in this lethal environment, the traditional metrics of fighter performance, roll rate, high-altitude speed, and turning radius became completely irrelevant. The only metric that mattered was absolute survivability. When a sleek, liquid-cooled fighter like a Mustang conducted a strafing run, it exposed a fatal vulnerability. Liquid-cooled engines rely on a complex network of radiators, hoses, and coolant jackets to keep the engine block from melting under its own heat. A single stray bullet from a German rifleman or a small piece of shrapnel from a bursting flak shell could pierce the radiator. Once the pressurized coolant drained away, the pilot had mere minutes before the engine seized, violently forcing a crash landing behind enemy lines. But the Thunderbolt was built around the Pratt & Whitney R2800 double WASP radial engine. It had no radiators. It had no liquid coolant. Instead, it relied entirely on the air rushing past its massive steel cylinders to keep it cool. The engine was essentially a massive block of armored steel, sitting at the very front of the aircraft, acting as a physical shield for the pilot strapped in behind it. When the P-47s dropped to the deck and began strafing German locomotives and armored columns, they flew into absolute walls of anti-aircraft fire. The heavy fighters began taking catastrophic hits, but to the astonishment of the pilots and the absolute despair of the German anti-aircraft gunners, the Thunderbolts refused to go down. A 20mm high-explosive flak round could detonate directly inside the engine cowling, physically blowing off one or even two of the engine's 18 massive cylinders. Oil would spray across the windshield, coating the canopy in thick black grease. The engine would shake violently, vibrating the entire airframe as it lost compression and horsepower. But because each cylinder operated somewhat independently, and because there was no central coolant system to quickly drain away, the massive radial engine would simply continue to rotate, violently hammering its way forward. Pilots found they could nurse a severely mangled Thunderbolt, trailing heavy smoke and streaming oil, back across the English Channel. The 7-ton mass that had once been considered a fatal liability in a turning dogfight now translated directly into rugged, unyielding structural integrity. The aircraft was absorbing punishment that would have instantly vaporized a lighter, liquid-cooled interceptor. As the spring of 1944 approached, the P-47 was cementing a reputation across the European theater as an unstoppable juggernaut. It had mastered the heights and was now dominating the lethal, low-altitude valleys of occupied France. But this growing legend of invulnerability among the fighter groups obscured a very harsh logistical and physical reality behind its success. The Thunderbolt was a metallurgical leviathan. Manufacturing a single airframe demanded staggering amounts of aluminum, making it one of the most expensive fighters of the entire war. Once deployed, its massive engine devoured high-octane fuel at a rate that actively strained Allied transatlantic supply chains. But the most immediate danger wasn't logistical, it was physical. The growing myth of its invulnerability completely ignored the unforgiving physics of its new ground attack mission. When a P-47 was strapped with high-explosive bombs, underwing rockets, and maximum ammunition for a low-level strike, it wasn't just heavy, it was dangerously sluggish. Pushed down to the deck, the aircraft was stripped of the very thing that had made it a predator at 30,000 feet: potential energy. Burdened with heavy ordnance, it possessed virtually no initial acceleration. If a roaming patrol of veteran German fighters caught a Thunderbolt squadron low and slow, before the Americans could build airspeed or jettison their payloads, the pilots were trapped. In a low-speed ambush, no amount of thick armor plating could compensate for a total lack of agility. Stripped of momentum, the heavy fighter would wallow in the thick air, trying frantically to accelerate while remaining a massive, nearly helpless target for German cannons. Tactics meant nothing if a pilot was cornered at treetop level with zero energy to escape. To survive in that hyper-lethal environment, the Thunderbolt could no longer rely on altitude or diving speed. It had to depend entirely on sheer brute mechanical endurance, an endurance that was about to be tested to its absolute breaking point. That breaking point arrived in the skies over northern France in June 1943 for a young pilot of the 56th Fighter Group named Robert S. Johnson. Ambushed from behind by a swarm of Focke-Wulf 190s, Johnson's Thunderbolt was instantly crippled. A 20mm cannon shell detonated inside the cockpit, severing hydraulic lines and showering the glass in blinding fluid. As the American pilot tried to bail out, he discovered a fatal mechanical failure. The shattered canopy was warped and jammed solid. He was locked inside a flying coffin. Bleeding altitude and nursing a violently shuddering engine, Johnson limped toward the English Channel. But he was not alone. Sliding into formation just off his wing was a sleek Focke-Wulf 190, piloted by one of the Luftwaffe's most lethal tacticians, Egon Meyer, an ace with dozens of Allied kills to his name. Recognizing that the heavy American fighter was utterly defenseless, Meyer casually dropped back onto Johnson's tail to deliver the executioner's blow. Meyer squeezed the trigger, walking lines of heavy 20mm cannon fire and machine gun tracers directly into the Thunderbolt's fuselage. The German ace systematically dismantled the P-47 in mid-air. He blew away massive chunks of the rudder. He shredded the metal skin of the wings. He poured armor-piercing rounds directly into the heavy steel cylinders of the Pratt & Whitney engine. Inside the cockpit, Johnson crouched behind his armored tub as heavy lead hammered against the steel plating, inches from his head. By every known law of aviation, the aircraft should have instantly disintegrated. But the massive radial engine simply absorbed the punishment, coughing out thick black smoke while refusing to seize. Meyer made 3 separate firing passes, pouring hundreds of rounds into the wallowing American machine until his weapon base clicked completely empty. Exasperated, the German ace pulled his Focke-Wulf up directly alongside the shredded Thunderbolt. For a long, tense moment, Meyer stared across the few yards of empty air, inspecting a machine that mathematically should not be flying. He looked at the trapped American pilot behind the oil-streaked glass, offered a slow, deliberate salute of absolute disbelief, and banked away, leaving the mangled P-47 to stubbornly drone its way across the channel. Johnson's battered aircraft eventually made it back to English soil, touching down safely despite carrying over 200 bullet and cannon holes. His survival was not an inexplicable miracle. It was a testament to raw, industrial engineering. The very bulk that had made the Thunderbolt the laughingstock of British and German airfields just months earlier had become the exact reason thousands of American pilots would survive the deadliest skies of the war. For decades, aviation doctrine had been trapped by a deeply romanticized view of combat. The lingering legacy of the First World War dictated that a fighter was supposed to be nimble, a graceful instrument built for horizontal turning dogfights and aerodynamic elegance. The P-47 violently shattered that illusion, replacing it with the grim, unforgiving physics of a mechanized world war. It proved that in a theater defined first by freezing high-altitude interception, and later by impenetrable networks of low-level flak, kinetic energy and sheer mechanical durability were far more decisive than a tight turning radius. The massive fighter didn't just endure the European air war, it fundamentally redefined how it was fought. It demonstrated that when a 7-ton machine learned to weaponize its own weight, the most effective strategy wasn't to outmaneuver the enemy, it was to outdive them, outgun them, and ultimately simply refuse to be destroyed. When Alexander Kartveli drafted the blueprints for his 7-ton Leviathan, he abandoned the romantic illusion of aerial chivalry for the cold, unyielding reality of industrial combat. The Thunderbolt was never intended to gracefully outfly the veteran aces of the Luftwaffe in a horizontal dogfight. It was a brutal, uncompromising machine, specifically engineered to violently outdive them, definitively outgun them, and when the skies turned to fire, simply out-survive them.